Hey guys, welcome to your lesson entitled I've Got Problems, where we're going to start looking at some word problems when solving linear systems. So places that we can apply all this stuff we've been learning regarding graphing, substitution, and elimination. Now, to help you out a little with problem solving, we've decided we wanted to talk a bit about the cubes method. So it's just an acronym. It's over on the side of your page here for some steps you could follow to try to help you solve a problem in math and try to direct you towards the right answer. So the first one in cube stands for circle. So circle all the key information. So with this question over here, when you rent a car, you are charged a daily fee plus a cost per kilometer. When Shanna rented a car for 3 days and drove 160 kilometers, the charge was $124. Now I missed one in here. For 3 days, there we go. When she rented the same car for 5 days, so this is another situation. I'm going to grab a different color here. All right, same car for 5 days, drove 400 kilometers, the charge was 240. So we have a bunch of information there. What was the charge per day and the charge per kilometer? Start your solution with let statements. So we've circled all the key information. The next piece tells us to underline the question. So I'm just going to grab my fancy underline tool here. What was the charge per day and the charge per kilometer? So the next step in cubes is to brainstorm steps. So what can we do? What kind of applications can we do to solve this problem? Now, because we've been dealing with linear systems, that gives us a bit of an indication of where your teacher probably wants you to go, okay? But ideally with math, if we can model things either graphically or algebraically, so if we can somehow model this with equations, okay, that's going to be helpful. Also focusing on what the question is looking for. What was the charge per day and the charge per kilometer? So there's two things we're solving for. We have two unknowns or two variables. So for that first portion, start your solution with let statements. Bam! There it is. Did you see that? All right. Let blank represent the charge per day. Let blank represent the charge per kilometer. So we're going to put in some letters to represent those things. Up to you what you use, X, Y, P, Q, whatever you want. In this case, I'm just going to let D represent the charge per day, and I'm going to let K represent the charge per kilometer. Make sure when you're writing your let statements that you're very clear. Don't just say let D be days. D doesn't represent the number of days. What do you mean by days? Okay, so it's the charge per day. K is the charge per kilometer. So make sure it's a nice, clear statement. Now, solving linear systems is a way of solving for two unknowns or two variables. So the way I've color-coded this, the first three that I've marked here in blue, those are all related to each other. So it says she rented a car for 3 days and drove 160 kilometers. If she was charged D dollars per day and K dollars per kilometer, how would you calculate her cost? What would you have to do? What if the charge was $3 a day and it was 50 cents a kilometer? What would that look like? And whatever that formula you're using to calculate the cost, that's what they used to calculate this number here. So what we have to do for that first part is 3 days times the charge per day. That'll give you the first portion of the fee. And then 160 kilometers were driven. Well, what do they charge you per kilometer? 20 cents, 30 cents, 40 cents. Whatever that number is, we would multiply it by 160. When we substitute those values in there, if we knew those values, the total number that got calculated was that $124. For the second one, now I kind of flip-flopped my color coding here, but this is 5 days. So 5 days times the charge per day plus 400 kilometers times the charge per kilometer. And when we tally that up, the total cost here is $240. And what we end up with is two different linear equations. So we can solve this and evaluate part of our cubes by using elimination here. So I am going to multiply both equations by the coefficient out front. So multiply the top one by 5, multiply the bottom one by 3. So I've got 15D plus 5 times 160, so 800K equals, that's 620 there. Bottom row multiplying by 3, 15D plus 1,200K equals 720. So here, because we have the same sign, we have to subtract these two in order to eliminate. 15 minus 15, gone. 800 minus 1200, we get a negative 400K. And 620 minus 720, negative 100. So continue on solving, divide out by negative 400 on both sides. And in this context, we do get a fraction reduced to lowest terms, you'd have a quarter. But because we're talking about money and the charge per kilometer, I'm going to write that as a decimal number. So the cost per kilometer here, that first piece, K equals 0.25. So if we know what the cost is per kilometer, we take that K value, substitute it into one of these scenarios, and we'll be able to solve for that other variable. So 3D plus 160K, and it shouldn't matter which equation you pick, just like all the other previous questions we've done. So we get 3D plus 40 and subtracting the 40 on the other side, trying to solve for D here. We get 84. Divide both sides by 3, and we end up with 28. So for your very final piece in your cubes is to always write a therefore statement anytime we have a word problem. So we're going to, and there you have it. Therefore, the cost per kilometer is 25 cents, and the cost per day is $28. It also says here statement and then verify logic. So when you're doing questions like this, let's say we made an error up here and we didn't get that negative number, we had a positive. Does it make sense that the cost per kilometer would be a negative number? No, it doesn't. So you would go back and analyze the question. There's nothing that drives your math teacher crazy more than having illogical answers that don't make sense, having negative lengths on the side of a triangle. Okay, so always do a quick double check. Does that seem to make sense? And then go from there. So for the next two questions, I'd like you to try to do this first on your own and see what you come up with or see what you're thinking about before you check in with the answers. So for the next two questions, all I want you to do is write your let statements. So defining those variables, what your X and your Y or whatever letters you choose to use, what they stand for, and making it very clear. And as well, trying to come up with two different equations here to help you solve this problem. Give it a try, pause the video here, and then come back to me and check in with the answers. All right, so here we go. For this first one here, I've got my let statement. So let X represent the first number, let Y represent the second number. If you've chosen to use different variables, that's fine. F for first, S for second, M and N, whatever you like. Coming up with these two equations. So the first one tells me that the sum of two numbers is 9. Sum, of course, means the answer of addition. So my first equation right here, X plus Y equals 9 is my first one. Second one's a little bit trickier, and there's actually a couple different ways you may have written it, rearranged it slightly from what I have. So I have 3 times one number, so I took 3 times my X, one of my numbers. This is going to be 15 greater than Y. So if I write equals Y, that doesn't make sense because I know this number is bigger by 15. So what I did is I also made the Y bigger by 15, and now they're equal. Another way you might have done it is taking that plus 15 right here and actually subtracted it on the other side. So you might have had 3x, subtract 15 to make it smaller, and now we can say that it's equal to y. So we've got our two equations, and we could solve this linear system whether we choose elimination or substitution. And for 2b, sporting goods, so he bought 3 footballs, 4 soccer balls, spent X amount of money. Mr. Math, similar situation. How much do footballs and soccer balls cost? So what I'm looking for is the cost of a football, the cost of a soccer ball. So notice my let statements, very specific. Let F represent the cost, okay, not just saying let F represent footballs. So to write up my equation, 3 times the cost per football plus 4 times the cost per soccer ball, and this is our total cost right here. So that's it for today, guys. Hopefully you're ready to come to class tomorrow and set up some equations and do some problem solving.